All right. Uh, it is Friday, August 26th. Yet another beautiful day here in Western New York. I'm riding solo today, although, you might see Taffy up here. He's going to keep me company, I guess. Any bets on whether that cat moves the entire live stream? Anyway, you'll notice our good friend Ken is not around, and I apologize, but we do let Ken take time off. I know it's terrible, but it happens. I was on vacation myself not long ago, and last week I was getting back into the swing of things, and we didn't have a ZD TV. We don't have a ZD TV queued up for today, but I did kind of come up with some ideas, or an idea, I guess you might say, which is all about custom PKI and OpenSSL. Usually we'd read the release notes, but there are no release notes to read. So that's going to make that pretty easy. So we're going to just jump right into it. If you're not familiar, there is a lovely place out on the internet that is called Discourse. And if you fly on out to Discourse and drop us a note, you'll get a message from me, most likely. Ken might offer some input. Andrew's been out there. Paul, I've seen Dave, our CTO. We've had all kinds of people contributing on the Discourse site. So really encourage you to check it out. One of the questions that's been kind of a hot topic lately is all around this subject of PKI, or public-private key infrastructure. And usually I think it's called private key infrastructure. I never know if it's public, private. So I just say public and private key because they both start with P's. And OpenZiti, and whether or not you can bring your own PKI to the party. You certainly can. And I'm going to just go over some of that with you today. Very loose stream we have going on today. If you want to go to the old chat and chat at me, that'd be pretty interesting. I've never had somebody chat at me yet, but if that happens, it's going to happen one of these days. I am positive of it. Then great, yeah, give me a chat. And otherwise, just sit back, relax, and enjoy me as I stumble my way through trying to replace an entire PKI. Hey, Lars, shout out to Lars out of the chat. Watch me as I stumble my way through attempting, and I will use that term very broadly because I have not actually done this before. We are doing this live, and it'll be a lot of fun. Hopefully it'll be a lot of fun. I know it'll at least entertain me. So we do have this fella out here. I don't know if it's a fella, this person, AV Dev, and they've been asking lots of great questions. And if we go out here and we look at this one, we've been going back and forth. Also, our good friend Gooselegs, also out there. And we've been going back and forth in this one big long thread about, how can I make my own private PKI? I've already got a PKI. Can I configure ZD with my private PKI? That sort of stuff. So I thought it would be an interesting topic to at least talk a little bit about, see how ZD is configured to use it, learn a couple of new commands, maybe a new tool you've never heard of before called OpenSSL. If you haven't, boy, oh boy, it's such a useful tool. And if you have, then cool. I look forward to people mocking me. Feel free. I encourage it. I do not profess to be an expert with OpenSSL whatsoever. And if you are, let's just dive right in, shall we? If you go out to your favorite prompt and you type OpenSSL, if you have, okay, maybe OpenSSL help. Hey, there's a whole bunch of stuff in there. You can see right off the bat, there's a whole bunch of stuff that comes up. Generally speaking, I spend almost all of my time on this guy down here, X509. X509 is used to provide lots of information about cryptographic material. And maybe I got to hit help again here too. Maybe minus help. Yep. Okay, we'll get there. There we go. But I mean, just look at this. Look at all these options. There are so many options that you can feed this thing in. I am not here to explain how all of OpenSSL works, but I am here to show you a little bit of the process that I went through just thinking about and preparing for ZD TV, right? I've never done this before, but I also don't want to bore you with all of the little research that I do as part of this. So there has been a little bit of research. I came up with this idea no more than 2 hours ago, so it's very fresh. And I did a bunch of research to figure out, exactly what are these commands going to look like. So of course, I went to the handy dandy Oracle of all information, Google, put in a Google search, and the Google search that I looked for, I've got about 800 windows open right now. I'm trying to find the Google search that I performed that gave me the site, which I really, really liked. I'm trying to find that. Here it is. Okay. Let's make it bigger. It was this one. OpenSSL conf file server cert. So I went out and I Googled for those things because what I needed to do was create a server certificate, but I'm also getting ahead of myself just a little bit. So this website that Google found for me, this guy right here, whoever, golinuxcloud.com. Nice job on this site, guys. It's got all the information I needed on it. You can see right here. You can make a certificate chain. You make your own CA. You can make your own client and server certificate. Lots of nice information on this site. Really liked it. Anyway, let's go back to OpenZiti. All right, here we are. So we know we have OpenSSL installed. If you haven't installed it, you're going to have it installed. The next thing that this computer has done is it has run the quick start. And when you run the quick start, another tip for you, if you haven't done it yet, if you source, where is the sourcing of the file? Export the path. Oh, it's going to be at the end. What is at the end? Where's my source? No. Nope, almost. Interesting. I thought for sure I sourced my... Oh. I know why. I've got to go to Amazon. I'm not at my Amazon machine yet. Let me SSH to the Amazon machine. There we go. You can see when I SSH there, I get this little message adding the path. That's because this machine has had the quick start run on it. And if I'm looking down here, this is the screen I'm sharing. So, so this machine has had the quick start run on it and has a Ziti environment already. And what I did is you can come down to, here it is. By the way, tip for you, if you don't know, the period command is like an alias for the source command. So I should just write source here, but I use period. I don't know why. But I can source the file at .ziti/quickstart, $parens hostname, $parens hostname.env. So I'll copy that real quick, and you'll see if I echo that out to the screen, you can see it wants to source this whole big file. And that's where the quick start wants to install all of its interesting things. So when I come in, I source that file. And then also next to that, you can see I have run the bash completions, which is really nice. If you haven't sourced that file, super recommend it, because then you can type cd e tab list tab, say identities, like this. You can tab complete all of these things. Also, Ziti comes, the quick start comes with a Ziti login function to get you logged in so that you can list your identities. Cool. Anyway, that's ancillary to PKI. Let's go take a look at Ziti home. Since I sourced that file, I have the Ziti home folder, or Ziti home environment variable set. So I could cd to that location. And then once I'm here, I can edit the host name.yaml file. Well, let me echo that first. You can see it just is this file. So if you see me vi the ip.yaml file, it's the same thing. And when we do that, let me make this just a little bit smaller for just the moment, because I want to just point out the fact that there is an identity section up here. That identity section consists of 4 values: the cert, the server cert, you can just skip over the value that doesn't matter, the key, and the CA. These are all really important. They all go together to form your whole PKI. You need them to be correct, otherwise you will get strange errors that are probably hard to debug if you've never worked around with this PKI stuff before. On top of that, there's another section down here in the Edge enrollment signing cert section, which is responsible for creating identities, whether they be enrollments for routers or whether they be enrollments for devices slash SDK clients, users, regular, quote unquote, regular identities. That's done by the signing cert. And then there's one more section down here under web. Well, in my case, there are two more sections because I've gone so far as to split off the Edge management API. It's only available on this 18441 port, which is different from the quick start. By default, you'll probably be on 8441. And it's only available on localhost. It's advertising localhost here. So I did that on purpose so that I would have my management API totally dark. I'm going to make it bigger now. You can see I get the same sections: CA, key, server cert, and cert. It doesn't matter the order. It's an array of YAML, and it does not matter. We're trying to go back to the top here. Go. There we go. Back to the top. Anyway, so this is where your PKI sits. When you do the quick start, it goes out of its way to make a complicated PKI. So if you were to take a look at this, you'll see that this is the location of an intermediate certificate. And this is your client certificate, which was generated for you when you run the quick start. If you take a note of the folder, it's in IP PKI IP172. If we go down again and we find that the signing certificate, you'll see it's got a different name, signing intermediate. If we go down a little bit further, you'll see this also has a different name, which is the name of the server intermediate. So there are basically three trust roots, if you will, inside of the PKI of OpenZT. You have the controller trust root, the controller, not the edge controller, not to be confused with the edge controller. The controller will handle the network itself, so the router, the controller, that sort of stuff. The edge controller has edge functionality enabled within it and is responsible for edge connections, so SDK connections. And then we have the signing trust root, which is used to produce those identities for authorization. For identification, not authorization. Authentication, that's the word. All right, cool. So that's a little bit of background. And so what we're going to do today, when you run the quick start and you create all these certificates, the quick start does all of this for you. Very, very friendly, that quick start. And the way it does that, let's see if I can find history. Pipe rep for Ziti. I'm just trying to get this thing right here. So this is the quick start functions. We're going to take a look at what it does. Oh yeah, we're going to call it funcs, I guess, .sh. And if you look through here, what you should have done, you should never run a script on the internet, right? You shouldn't trust me that we're not nefarious. You should have read this. I'm sure everybody does, just like when they read all of the terms and agreements to their EULAs. But if you come down here and you look for, well, let's look for PKI. So the Ziti command, in fact, if I come up to the top, I can do both at once. If I do Ziti PKI, you can see the Ziti command has a Ziti PKI create functionality associated to it. And so what will happen when you run the quick start is you'll get a bunch of certificates made for you. It'll run this PKI client server function, and that client server is going to go out and it's going to make your key and your certificates that are all necessary, but it's going to use Ziti to do that. So two options. If you want to use Ziti, the CLI tool, to run your personal PKI, you can do that. And, you know, fun fact, if you've run the quick start, you already have your own custom PKI. You can do whatever you want with it. You'll have all the keys, all that crypto material is on that machine. You'll have a couple of root certificates. You'll have a couple of intermediate certificates. And if you want to get really cautious, you can move those private keys, the root certificates, the root CAs, away from the computer and only use the trust root that's at the intermediate level. I'm not going to do that today. We're going to keep it as it is because I'm probably going to fill the whole time just blathering on about this anyway. All right, so where were we? We were looking at our config file. Let's go back and look at that config file. And we had 4 fields of interest to us. Oh my goodness, too fast. All right. One field being the cert, one field being the server cert, one field being the CA, one field being the key. Now, we always need to start with the key. All of these, I should say, both of these certificates, the cert and the server cert, are closely related to this key. The key is basically the other half of the certificate. It's what allows you to cryptographically prove that you are the owner of the certificate so that when you establish a TLS handshake, you can do so. The CA is used by the other people who are trying to connect to your server. So the basic TLS connection, a client somewhere wants to connect to some server somewhere. So that client goes to, say, google.com. So client goes curl google.com. The client says, hey, server. The server says, hi, I'm this server. And the client says, okay, you're that server. You said that you're that server. I have a certificate that says that you're that server. That's really great. And it goes through the little dance to prove that. And then if you have a mutual TLS sort of setup, the client can exchange a certificate back to the server that says, hey, server, I'm the client. Generally speaking, TLS, I would say, in my experience, is usually one way. It's not mutual TLS. It's usually one-way TLS. So the server has some cryptographic material that can prove that the server is who the server says it is. And when you connect there, the TLS protocol checks to say, hey, you were trying to go to google.com. This guy says they're google.com. They've proven that that they have the certificate that is valid for google.com. And it has a trust root that you trust, and that's also important. We'll get into that in here in a second. And so because of all those things, then you're good to go. That actually is google.com. So let's just, for a real quick second, go to google.com. You know what? No. Let's go to netfoundry.io instead. Since I work for NetFoundry, you might as well use NetFoundry's website, right? All right. So here's NetFoundry's website. You can see it's got the little lock icon, very safe and secure. We click this thing open. It says the connection is secure. It says, hey, there's a, let's see, where's the certificate? The certificate is valid. Fantastic. Let's look at that certificate. I don't know if that's going to be big enough. Let's see. I don't know if I can end big in that. No, I can't make it any bigger. You're going to have to trust me. I don't know how to make that little guy bigger, and stupid Windows doesn't have a real great zoom tool, or at least I haven't found one. I should buy one. But you'll see it's got some certificate information. It says when it's valid through, in case our certificate is valid until 2023. But the important part, for starters, is this certification path. And what this is basically the chain of trust. So a certificate was delivered from the netfoundry.io domain to your local computer and said, hey, here's the certificate. It was signed, or it has an issuer from GoDaddy. And GoDaddy has a certificate that says, hey, I was signed by this root. And this root says, hey, I was signed by this root. And so what has to happen on your local computer for this all to work out and for you to not get the scary, this site is untrusted, is you really need to have this whole entire chain in your browser. If you don't have the whole chain in your whole browser, then it's going to be scary. It's not going to be able to be verified, and your browser will tell you, hey, this site is not valid. In fact, if I were to go to my machine, which is this URL right here, you can see that in action. Let's move the certificate. Paste. Oh, 8441. Oh, not secure. So scary, right? Well, it's not scary because I own this site and I've run this site, but it's telling me my connection is not valid. My certificate's not valid. If I look at this path, it says, hey, this was signed by this intermediate. Remember before I was talking about the root certificate or the trust root? because it's not always the root certificate. In this case, it's just an intermediate. So it's not actually all the way back to a trusted root. But that's okay because I trust the site. Our NetFoundry certificate, on the other hand, has a certificate that is valid because somewhere along the lines we have one piece of this trust root in our browser or in our operating system already. And this is almost certainly going to have the GoDaddy certificate in the operating system. Windows almost certainly has that certificate preloaded. And then from that root certificate, all these other ones are generated. I don't know how many of these come down from our site. It might be 2 of them. This one might be in my OS. It might be all 3 of them, and only this one is in my OS. I just don't know. That's not important for right now. But if you find that important, go check it out because learning how that works is kind of interesting. One more interesting bit in here is subject alternative names. So here's an extension to the X509 spec. I don't know if it's an extension or not. Maybe that's the wrong word, but here's a property of X509 that's called the subject alternative name. And this is a little field that contains the names that your certificate are valid for. So if you go to like bob.netfoundry.io, this certificate, if it's returned, it'll say, yep, you're good, because it uses a little star and it says this is a wildcard certificate. It's good for everything. All right. So that's a little tiny primer about how a certificate is validated in your browser, why it works for NetFoundry, why it doesn't work for the Ziti controller, and why it's okay that this certificate is not valid for your Ziti controller. It's your certificate. You own it. This is your PKI. What I could do is I could get this certificate and I could put it into my browser. And lots of enterprises will do this exact step. They'll take a certificate that they've created, they'll put it into their image of their operating system, and then it'll just be there. And that will let them create a certificate, create a TLS connection that is valid for your computer, because that computer has already established its trusted root by having an image that was trusted, by having a certificate that is in your operating system that is also trusted. And that's why my certificate shows up as not trusted, because I have not done all those things. And I like to see that it's not secure, and it doesn't scare me at all. Also, we should talk about what a certificate authority is, the CA. A CA is just a certificate that is self-signed. That is exactly what it says. It's a certificate that signs itself, and the root of every CA is a self-signed certificate. But it's okay because, as we said before, these self-signed certificates are globally trusted and have a real strong chain of trust associated to them. They're cryptographically provable, or I don't know of a better word than provable, but you can, because it's using the X509 spec, I don't know the right word, because it's using that cryptography, I don't know a better way to state it. It's globally trusted. The root CA is in your operating system. You can trust anything that presents as being issued by that. Anyway, little primer on there for you too. So now let's just dig into this, because what I want to do is I want to replace this certificate here. And you can see this certificate was created probably, last month sometime. I don't know what I was doing, but I had to regenerate my PKI probably for a discourse post. And so I regenerated it. So keep an eye. In fact, maybe we'll take a screenshot and we'll say, oh, you know what we'll do? We will get the serial number, because this is embedded into the certificate and is not non-fungible. I'm not going to use that term. Not able to be mutated without changing the certificate. The certificate is cryptographically solvable, provable. I don't know what the right word is. I got to find what the right word is. And so when you create this signature, it uses the certificate itself and thus is verifiable. That's the word, cryptographically verifiable. So this serial number, if it changes, we'll know that we have successfully changed our certificate. So I'll just take a little screen cap of that and put it somewhere else. And now what I want to do is I want to change that certificate. So this is where we get into the whole fun stuff of watching me flounder and seeing if I make a, if I make it or not. We're gonna go to the root folder here, and I'm gonna narrate as I go. I'm probably gonna make this a lot smaller for now, just to keep that bigger. I'm gonna make a new folder, and we're gonna call this what, Ziti TV, I guess. Ziti to Ziti TV. And inside of here, when I was doing my own little research, I had remembered, because when you're using OpenSSL and you're creating keys or certificates or performing operations with it, sometimes you can feed it a configuration file. And I remembered, hey, last year, well, no, 2 years ago, Andrew and I were talking about how we can perform the desktop edge for Windows automatic upgrades and how we can feel better about the cryptographic signature provided from the download. So we made this CRO library out here. You can read the README if you want to read the README. But one of the things that we did is we made a root certificate authority for OpenZiti. And here was the command I used. In this case, I used RSA as the key type. You can use an elliptical key if you want, elliptical curve if you want. It's a little bit more wordy. So I'm just going to follow all of these steps because I realized, hey, I already have all these. What I was talking about before, the config file, you can see I've also already got a config file. So I'm going to just start by cloning this repository. Okay, and then we'll cd into CRL, and we'll just use this as a jump start. So if I come back to my little notes that I left behind, I made a new key important. So everything starts with that key. That's the really important bit. Go ahead and do that. Chug, chug, chug. So now I should have an OpenZiti.root CA RSA key updated. What date is it? 1627. All right. So you can see that is accurate. I bet if I look at the clone directory, it's probably the same minute. Let's see. Let's find out. Yes, it is. So should we? How many more seconds was there? 40. Let's see. Can I get to 28? If I get to 20, all right. Yeah. All right. Now when I run it, now I should have one, which is on 28. And just prove that it's different. There we go. Yeah. You know what? I probably could have just done a git status too. Oh no, the key's not going to be committed. Never commit your key into GitHub. Actually, when you do that, GitHub will probably tell you. I don't know if Git will find it before you commit, but I think GitHub will reject your commit and tell you that you've tried to commit a private key. You can always try it. Just make a new private key and try to commit it and see what happens. All right, so there's our private key. So I didn't even have to verify it because there's no way I would have committed it. That was silly of me. See, floundering already. Next, I want to make a certificate from it. This certificate is then going to be used to sign other certificates. So if we take a look, we're going to look at the OpenSSL conf for a second. Let's take a look at that. And this looks complicated. Oh my goodness. You can go out, clone it, and use this one if you want. It's just got a bunch of stuff that's set in here, like put your certificates into the certificates folder, make a database called certdb.txt, blah, 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 really. Let's go down to the important parts, though. Here's some important parts. We want the subject key identifier equals hash, not important. Key always critical, CA true. That's probably the most important bits inside of here. Everything else is not important in this config file, but that's the important bit. CA is true. All right, let's go ahead and make ourselves a, this is going to be a request. So it's not a certificate yet. It is a CSR that we're going to make. And we're going to make that, are we going to make a CSR yet? No. What's the CSR command? Yeah, it is Rick. Looks like we're just, oh, it's a self-signed certificate. So it's going to pop it right out. That's why. That makes a lot of sense. All right, we're going to use the config file. We're going to use that key. We're going to tell it how long it's valid for. We're going to use this subject, and we're going to tell it to pop it out into that folder. So if I go ahead and run that, presumably it'll work. Now if I do a git status, it should show me that this thing has changed. If I diff it, okay, look, it's different. Fantastic. So we actually did create a new certificate, and we can check it now. So we can run OpenSSL x509. We can give it an in of certs and OpenZT root CA, and then we can say, show me the text. When I do that, if I scroll to the top, you'll see the serial number. You'll see who signed it. This is the issuer. You'll notice that the issuer is the same as the subject, and that is the definition of a self-signed certificate. A whole bunch of material we don't need to read. And then there you go. Basic constraints. CA is true. And ta-da, we have a self-signed root certificate. So that was painless. If we go back and look at ZT home host name.yaml, you can see I have a key now. I made a key. If you remember, I made a key, but I didn't make a server key. So I'm actually going to need to make a server key now. And then after that server key, I'm going to make a server certificate, a cert that is presented by a device being connected to, and then a client certificate, the certificate presented when this device connects somewhere else. I don't think the controller actually connects to anything at this point in time, so I don't know if that cert is particularly useful, but we'll make it anyway. All right, so we have to make a key. Now, I use the same set of instructions that I said I found on that wonderful Google site. Let's go back and give them some more love. Where is that? I'm going to find that Google site. Here it is. Oof. All right. So I'm going to make the client cert first. And so I used, you know what? Let me just bring up my, I got my own little notes that I ran. Okay. So I need to generate a server key. So let's go ahead and make a server key. Looks like this. OpenSSL NRSA server.key. How many bits I want to use? I just used a bunch, right? Now we need to create a certificate signing request that is able to be signed by our CA. To do that, OpenSSL request new key server.key. Out is client.csr. The subject is common name equals, what is this common name? Copy the big old DNS name. Boop. Okay, so now I should have a client CSR. I do. All right. I'm going to use another config file. So I've already got the copy and the paste over here ready so that we don't have to watch me do all of it. We'll do client.conf and we'll paste in the constraints and the settings and the stuff that OpenSSL wants. So it's not a CA, so we say basic constraints CA is false. OpenSSL generated client certificate, it's going to be for client, and for email, it has a non-repudiation key usage, I guess. I don't know what else to call this thing. Property that gets embedded into the certificate. It's good for digital signing and key encipherment, and that's what you need. And it's for client auth and email protection. I just copied and pasted it, so I didn't bother changing it. Let's write that out. And now, OpenSSL x509 req in server dot, where's my, oh, it's client, that's why, client.csr. And then I need to give it a CA, which is certs OpenZT.root CA PEM. CA key is OpenZT.root key. I want to pop out client.pem. CA create serial CRIAL, which I believe updates the CA. I don't really know. We should also, I said before, I'm not a pro. I just copied this one. Don't really know what CA create serial does. Don't feel like figuring it out right now. I'm sure you don't either. So let's just keep it going. We'll keep it rolling. Keep it rolling. All right. How many days we want this valid for? We'll make it 365. SHA-256, and then we will give it the ext file of client.conf. And let's hope I typed it all correctly. Looks like I did. So now if I do an ls, I should have a client.pem. Fantastic. Again, we can verify this using OpenSSL. OpenSSL x509 in client.pem. Show me the text. Okay. OpenSSL liked it. We can see that it was signed by our root signing CA. Now, that was, I think, where was that? Was that either, I don't know if that was in the actual, where is root? Yeah, right here. It's the CA, it's the CN of the subject that we gave when we made our certificate. So it was signed by the root. Also, I'm not saying this is the best practice, right? Like, it certainly is better to have a signing certificate that is cut from the root CA. You have an intermediate CA and then have certificates from that so that you can move the rootiest of the root, the actual CA, off the box like I talked about before. I'm going to skip all that just because it's already 36 minutes in. Let's see. I don't know. Hopefully we'll get through it. So we can see it's issued by that CA. Has some more information. We'll see that it is not a CA. We get our little comment in here. And then we see it's useful for digital signature, non-repudiation, key encipherment, and email protection and web client authorization. Now, or authentication. What we can do is check if we look at the CD home host name dot YAML. You type it wrong. Host name. Oh yeah, I gotta SSH the CD AWS again. I keep forgetting that that's not my. We'll get there. There it is. We can see what the existing one was set up for. So let's do the same X509, OpenSSL X509. Give it that file. Send out the text, and we'll compare to what Ziti, the PKI from Ziti created. CA is false. CA is false. Digital signature, non-repudiation, key encipherment. The key bits, same. And you can see nothing else, no extra fluff in the Ziti PKI created cert. So far so good. That looks like it worked. Now we need a server certificate. Let's try that. OpenSSL, make a request, new, key is server.key, same key, but this one's going to be the server.csr. This subject is the same. I'm just going to copy and paste that stuff. Okay, so now we should have a server.csr file. Excellent. Now we need to make our server.conf. And again, I have all this stuff off screen copied. I'm going to just plop it in here. Also not a CA. It is good for server auth. It is good for digital signature, key encipherment, non-repudiation. But for those of you who have been following the discourse posts, this little bit right here might show up interesting to you. We talked about the SANs before, the subject alternate name. And you can see in here, I've gone through and added some information. In fact, I can see I have a bug in there too. I didn't fix my IP address. Oops. Right here, I don't have a comma. That was a bug I had before. So you can see I'm basically instructing the certificate to be created with this sans field, because this is where I expect it to come in. Since I copied this, docker.local is there, but I'm going to just leave it. Localhost always is a good one to have on there too, always valid. In the same vein, the external IP address, or the localhost IP address, 127.0.0.1, good idea. And then here's the external IP address, 18.188.281, all that sort of jazz. So there's that server certificate. Now let's see, OpenSSL x509 minus rec days. Make it good for another year. It's 365. In is the server.csr SHA-256. Give it the CA that we're going to use again, which is the certs OpenZD root CA PEM CA create serial. I'm going to look up what that does after. Minus out. This is server.pem. And we're going to use the ext file of server.conf. And then this little bit I don't know if it's necessary or not, but I'm going to copy it because this was in the blog post. Extensions server. Unrecognized. Extensions, ext file. Did I copy something wrong? Let's try this again here. OpenSSL 509. Oh, was it X? Yeah. Minus rec days 365. In server SHA CA create serial out ext file. Minus extensions. EXTENS. Extensions. Error loading section server. Oh, interesting. So the configuration file needs, apparently I didn't realize that. I took this out because I thought it was extraneous, but it was not. It needs a little identifier that says that it's for server. Okay, we're getting somewhere. Unable to load the private key. Did I give it a private key? I don't believe I did. Where is the CA key in there? Okay, let's give it a CA key. That should be CA key is OpenZD.root CA.key. Bingo! Now we should have a server.pem. Hey, okay. I think we're there. Oh, CAs. Well, let's see what happens when we get the CA bundle. I haven't made the CA's bundle yet. Should just be the CA certificate now that I think about it, since the CA certificate is it going to be good enough? I think that's going to be good enough. I think we'll just be able to. So let's go ahead and see if we can't. Let's see what happens. We'll edit this file. You know what? We'll copy this file first to ZD home / IP YAML. Oh, go away. YAML.back. There we go. Now we can VI that file. Now we can delete whatever we want to. All right, so let's delete all of this. We want the path to the certificate. And this was client.pem. Come down here, delete the whole row. Server, delete $ after. Server.pem. Okay. Key, $ after. I do believe it was key. I will check that though because that's important. Indeed. And then our CA file should just be, I don't know what I called it. Okay. Certs / root CA. Okay, so that is our identity. Now I am going to go down to the signing certificate. I made a signing certificate. Did I make an actual? I don't think I made the actual signing certificate, did I? That's the self-signed one. Now I need to do all this over again, but I'm going to do it for the signing key. So let's change up to directory and make that key. Now I should have an OpenZT signing key. Okay. And now create a certificate signed by that. Generate the SR. Yep. Signing key. All that looks okay. Make the CSR. Now I should have a CSR. All right. Now I can make the certificate. Okay. Okay, all that looks good. There's already a certificate in there. Let's do an, well, let's see. We're going to make a 2022. Already a certificate for the same CN. We're going to make that CSR again. Here's what we need. This one needs to be 2022. Where's my cursor? There it is. Call this 2022. And now we should be able to make our CA. Hey, right database with one new entry. If we look at the certs, we should see a signing certificate. Okay, we're almost there. Almost there. At least we'll see if it works or if it goes up in flames. Like I said, I did not actually test this, so we're doing it live. All right, the cert. Let's see, after this is going to be BWD, this slash certs slash this guy, and then we need to give it a key. Going to be all the same stuff. But it is signing RSA key. I should have called it 2022, right? Okay, there's that. And now the one more thing I'm going to do is I'm going to go down to all of my web sections, and I'm going to get rid of the identity section for each of them by simply commenting or changing the key name. Good little trick. You can just change the key name and it won't be found. All right. Now, if I did everything correctly, if I did, this should at least start. Let's do a journal. FU on ZD controller. That is not controller. CONTROLLER. Okay, there's that. And now we do a sudo systemctl restart ZD controller. Okay, let's see. Okay, now things are going to be angry because I've changed the whole PK out from under them. So my edge router is going to be all grumpy. My local ZD desktop edge for Windows is going to be all grumpy, right? So that's what this is. That's why you see all this stuff happening now. Let's go ahead and look at our certificate. Where did we do that before? You can see all my windows I have open. Let's see, EC, here it is. Okay, advanced, proceed. Oh, I didn't need to do that. I can just do it right here. Certificate is not valid. Certificate path, you can see the path has changed. It doesn't have a path on it. Let's see if the subject alternate name has docker.local. It does. And then if we look at the date, 22 to 23. That's mostly successful. That's exciting. Now, one of the other cool things that you can do with OpenSSL is this S client command and connect. And you can connect to a listening machine and see what kind of certificate it's returning back. So we could have also used OpenSSL to return this stuff. Now you do have to pipe it back through OpenSSL x509 minus text. And then let me put that on the screen for a second. OpenSSL S client minus connect, the URL, the port, pipe it into OpenSSL again, x509 again, and get your text out. And when we come up here, we should see the issuer, and the issuer is the root signing CA. That is the one we wanted. The serial number on this certificate should be different. I mean, we've basically already proven that it will be. The other one was 306C. This is 0895. And there you have it. That's the basics of how you would rip out your PKI, not use the ZD CLI that does all this for you and probably does it a bit easier, and let you use OpenSSL. Maybe you learned a few OpenSSL tips and tricks. Maybe you'll go try to replace your information now. If you have any questions about ZD TV, you can put them in the chat. I'll get them later because I'm going to shut down the stream here. It was a success, which I was not certain that it would be. I'm very pleased that it was a success. And thanks for watching ZD TV this week. We'll see you guys soon. Bye.